Exponential notation is just a shortcut of writing multiple numbers out. Instead of writing multiple numbers out, writing them in sort of an abbreviated version. So when I look at this first one, I have 5 times itself 1, 2, 3, 4, 5, 6 times. So instead of writing out 5 times itself 6 times, I'm going to use that idea of exponential notation. So the base is the number that we are doing the multiplying by. We're multiplying by 5. And how many times is the exponent? So how many times did we have 5 multiplied by itself there? We had it 6 times. So the base is the 5, and the 6 is the exponent. So when I look at the second one, I have a fraction. Fraction, we can simplify that in sort of a different way, write it a different way. So the base, the number that's being multiplied, is 9/7. That's our base. And our exponent, how many times do we multiply 9/7? 4 times. Down to number 3, still changing it up slightly. We have a fraction still, but now we have parentheses and we have a negative number. But everything that's inside the parentheses is being raised to the 3rd power. So they're saying, okay, well, what would be the multiplier? The multiplier, or the base, would be that -4/11. And the exponent, how many times would we multiply that? We'd multiply it 3 times. So if I were to expand that out, I'd make sure that I would keep my parentheses there. So it's -4/11 times -4/11 times -4/11 a 3rd time. So as you can see, writing it in exponential notation is certainly a nice little shortcut. So when I look at number 2, same thing. Okay? The base, that number that we are doing the multiplying by, so it's the base is -2. That's what's inside the parentheses, and it's all being raised to the 6th power. So if I were to expand that out, I would have to write out -2 times -2 times -2 6 times. Now, as you can see, what I have chosen to do is I've chosen to use parentheses to indicate my multiplication instead of the X we've used for the multiplication sign, because sometimes as we get later on in math, we'll start to get away from using that X as multiplication, because that will start to be a variable once we get into the algebra. And the last question on this page, we have 3.8 to the 4th power. So we have a decimal, but it still means the same thing. It's just that shortcut way of writing 3.8 times itself 4 times. So the number that is being multiplied 4 times is 3.8, and the exponent is 4. So when I go up over to the side here to look at some of our summary here, it says, did you notice that parentheses are used in 3 and 4? Why do you think there are parentheses? So the difference in 3 and 4 is we need those parentheses because notice in 3 and 4 we have negative numbers. So we need to make sure that we're not just raising in number 3 4/11 3 times. It's -4/11. We have to sort of tuck that negative in and make sure that that gets multiplied too. So because everything inside the parentheses is raised to that exponent. All right, so let's take a look at this vocab here, and let's relate it up to, say, number 1. So back up to number 1, we had 5 times itself 5 times, and it says that we came up with the base is 5 and the exponent is 6. So the number is called 5, and you've heard me say this throughout the lesson, 5 raised to the 6th power, and then it says blank is the exponent and blank is the base. Well, we just identified that when we were going through and answering this, and we said that 6 is the exponent and 5 is the base. All right, go ahead and flip the page. Let's take a look. It says that Josie says that negative 15 in parentheses times itself is equal to this negative 15 to the 6th power. Is she correct? And how do you know? So I look at it and I say to myself, well, in this part of our equation, what is the base? I would identify the base to be what is inside the parentheses. So my base is negative 15. And my exponent is how many times it's been multiplied. So I see 1, 2, 3, 4, 5, 6. So that would be 6. So if I were to write that in exponential form, I would say parentheses negative 15 to the 6th power. So what did she leave off? She left off her parentheses. So right now, is Josie correct? No. Okay. She is not correct. Okay. So we need to be very careful when we have a negative number that we put our parentheses or grouping symbols around it, okay, when we're writing it in exponential notation, because this negative 15 to the 6th power is not the same as what truly is equivalent to negative 15 times itself 6 times. Number 7, if we're to expand negative 3/4 in parentheses to the 3rd power. So to expand means write it out. Okay, there's our base, our negative 3/4 in parentheses times itself 3 times. Okay, so expanded form is showing all that multiplication, and then our exponential form is showing it base raised to the exponent. So we have a bunch of exercises here following this. So if you think that you understand this, by all means, you can go ahead and skip over to exercise 11. I'm going to go through just a few of these on this page to take a look. So it says here, 4 times, ... times 4, and then underneath it, it says 7 times. So how could we write that answer? We would write that in exponential form is 4 raised to the 7th power. Number 6, we have a fraction. 7/2 times ... times 7/2 equals, and then underneath it says 21 times. So they didn't want to write that out 21 times. So my base is 7/2, and it's raised to the 21st power. Okay. Down in exercise, whoops, I skipped over to exercise number 6. But backing up and going to exercise number 2, it says 3.6 times, and then it says 3.6 to the 47. So how many times are we multiplying 3.6? 47 times. That's a lot of times. That would be a lot of 3.6s to write out if we didn't have our nice little shortcut of exponential notation. And let's keep going across the page to number 7. Negative 13 times itself 6 times. If we're going to write that in exponential notation, notice the parentheses around that negative. So negative 13 is the base, and 6 is the exponent. Okay. We'll do a couple more here. Let's jump down to number 10. Number 10 looks a little bit different. Instead of having a number, we have letters. Okay, we have x times itself, or x to the n power. So how many times would we have multiplied x? What is our exponent here? Our exponent is n. N times. N could be any number. Okay, we could pick that at any number to represent n. right? And over to number 11, those of you that maybe skipped ahead to number 11, hopefully this is where you're starting now. It says, will these products be positive or negative? And how do you know? So how would we know -1 times itself 12 times? Is that going to be positive or negative? So I always like to relate back to something that we're really familiar with. So if you have a negative times a negative, you know that that's positive. But what if, so we had two negatives give us a positive. But what if we wrote a negative times a negative 3 times? So a negative times a negative we just said was a positive, and therefore a positive times a negative you know to be negative. So there's sort of a little trick here that ends up happening. If there are an even amount of negatives, okay, 2 is even. 2 is an even number. So an even amount of negatives is going to give you a positive multiplication answer. But if you have an odd amount of negatives, which in this second example we had 1, 2, 3 negatives, our final answer came out to be negatives. So when I look at my example, my exponent is 12. I would end up with 12 negative 1s multiplied by themselves. So that would give me 12 negatives. Is 12 an even or odd number? It's even. So if it's an even number, we know that if we multiplied, we would end up with a positive number as our final answer. So in the next one below it, our exponent is 13. 13 is an odd number, so therefore my final answer is going to come out to be negative. So it's sort of a nice little shortcut to see that pattern, that if your exponent is even, you're going to end up with a positive answer. If your exponent is odd, you're going to end up with a negative answer. Okay? So we look at something crazy like this next one, this -5 times itself 95 times. Would the sign of this be positive or negative? Okay, is it necessary to do all these calculations to determine the sign of the product? Why or why not? Well, right now, absolutely not. We don't want to multiply -5 times itself 95 times. We just have to examine that 95, and 95 is an odd number. So we know that if it's raised to an odd number, our final answer is going to be negative. Okay. So an odd exponent gives us a negative answer, right? Or negative product. So in the one below that, our exponent is 122. So what would the sign of our final product be, or our final answer? Because that is an even number, an even exponent, our final answer, our final product is going to be a positive product, or positive answer. So a nice little shortcut. Okay. And the last part of this, it says fill in the blanks whether the number is positive or negative. So it says if n is some even number, -55 in parentheses to the nth power, if it's an even number, our final answer should be positive. Even number gives us a positive answer. And in the next one, an odd number. If n, our exponent, is an odd number, our final product is going to be negative. And it looks like we have a repeat here, so we can cross that one out. One more quick example, little review on the next page. We can cross that one out too. I think that one was repeated. What is prime factorization? Okay, prime factorization. So let's look at an example here of 92. Prime factorization, we're going to do a little factor tree. And I don't know, the one that comes to my mind is 2 times 46 gives me 92. Well, 2 is a prime number. Okay? You can only think of 1 times 2 as factors of 2, but I got to keep going with that 46. So 46 is 2 times 23. Right? Obviously, use your calculator if you need to. If your mental math skills are up, that's even better. Okay, 2 times 23. And then I say to myself, 23, is there something times another number that's going to give me 23? Or is 23 a prime number? Meaning the only thing that can be multiplied to give us 23 is 1 and 23. And I think that is it. There are no other factors of 23. So what would be my final prime factorization here? How could I write my final answer? How many 2's do I have? I have 2 times 2 times 23 should equal 92, but let's write this using our exponents. 2 to the second power times 23. There's our prime factorization.